Hi, my name's Al. I live in Silicon Valley. I'd like to discuss my home monitoring project using a Raspberry Pi and in general the Internet of Things. Internet of People has got about 3.2 billion attached in 2017. Internet of Things, things connecting to other things, 50 billion expected in 2020. Here's some things you can expect. In my own home I have a air conditioning control and heater control, so I can monitor the temperature and set it remotely. Many people have lighting controls, security and alarm, a door, motion, window control, and so on. These are the things that IoT talks about connected to the internet. I have a smart meter and I can monitor it remotely on an app. Google bought Nest for over 3 billion. Nest is a home thermostat. And with this app, you can monitor the temperature and you can set the heater or the air conditioning on and off remotely. It's very nice. Here's my IoT project. It's for home monitoring. I'll give you a design overview and some results. I had a problem. A few years ago, I had a stuck toilet valve. I wasn't home, and it just leaked. It didn't cause any damage, but the water went down the sewer, but it cost me over $1,100 because of this 3-day leak. And then another time I had a leak of my garden irrigation system. I didn't even know it was leaking, and it cost me about $900. And I thought, this has to stop. So I did something about it. Here's what I did. I decided to put in a water flow monitor in line with the main cold water. I went to watermeters.com, of all places, and I found a device that has a physical meter on it that's not used. It has a wire coming out, basically one closure per gallon. And that closure can be used by downstream processing to decide whether to send an alarm or not. The most expensive part of my whole project was hiring a plumber to put this in. That was very costly, actually. I decided to put some motion sensors inside my house in various rooms. While I'm doing this, I might as well add this, and I decided to monitor my irrigation. Now in this case, I'm just monitoring the voltage across the solenoid that turns the water on and off, and it's either 24 volts AC present or not present. Difficult to send this signal to the web directly. I'll show you what I did about it. I had to, if you will, condition the sensors before they went anywhere near the internet, both motion, water, and irrigation. Water, for example, was 1 gallon per click. And by the way, that water meter has 1/8 of a gallon resolution per minute, and it would not detect a pinhole leak. If you want to detect a pinhole leak, you better spend a lot of money. It's very hard to do that. But anyway, this will get certainly the lion's share of problems that most people have. So this conditioning system that I built basically takes in these signals and puts them into a logical 0 and a logical 1 or 5 volts for this unit. I had to use an optical isolator here to get the 24 volts AC converted to 0 and 5. So now this is very, very friendly logic here. This device from Moxa basically has simple logic if then else, and it sends an HTTP command or calls an API for some services I built on the web. For example, if there's more than 0 gallons of flow during a 30-second period, then, if then else, then call this web service that I built. So in the cloud, just basically on a web server, I built 5 services, one for water, one for motion, one for irrigation, one for configuration, and one for arming and disarming the system. And this decides if the water flow is a problem. If I'm home and there's water flow, that's okay. If I'm not home, then it's a problem. So there's logic in here. It also sends alarms and warnings to my phone through SMS messaging, and it plots graphics. This is the concept. The overview is the 5 web services that I built with their exposed APIs. They're password protected. The Moxa unit basically takes the signals from the sensors and decides when to send a API call to one of these services. It doesn't hammer it. It kind of filters out the stuff that's not important. The services process sensor data, as I mentioned, including keypad input. The services are written in PHP and about 700 lines of code here. And all these services basically decide when to send alarms and when to plot. Unfortunately, it didn't work. It worked actually for a while really well, maybe a week or maybe a month. During operation, on occasion, a web service would take too long to respond and the MOX unit would time out and hang. This was very hard to debug, because if it works for 2 weeks and then for just one moment the MOX unit hangs, it's hard to know why. And it turns out, through a lot of testing, the web service basically was just delaying its response to the MOXIE unit. It calls, it expects a response, it times out. It never explained why it timed out, it just hung. So after a lot of fooling around, I decided to go plan B. And I decided to port my 5 web services that were running in the cloud to a local Raspberry Pi. You can learn more about that on the web. No delay issues here. Instant response when there's an API call. And no monthly fees. I didn't want to pay for enhanced web services to reduce the delay problem. So here's what it looks like now. The same sensors, the same sensor processing, the same MOXIE unit, but now instead of the cloud I have a local Raspberry Pi. It decides when to send an alarm, when to send a warning, when to plot, and so on. Do I still need this? No, actually I don't. I could just take this digital level here and send it into the Raspberry Pi. I already had this working. It's debugged and it worked. So as I ported my code to the Pi, I decided to leave this alone, and I have no regrets actually. So here's a bigger picture of it. The sensors, sensor interface logic, and conditioning. I decided to leave this in. So this would send an HTTP call to my 5 services running here. And one of the things this would do is allow for configuration. One configuration, for example, is what's my phone number? There's actually quite a few configuration fields here when you get down to details. So this has the rules. It also goes to a plotting website called Xively.com, and I'll show you an example of that. So I can get plots of all the activities of the sensors. And I can arm and disarm it from my kitchen, or I can arm and disarm it from the web form. Here's an example of the Xively website. I'm showing 3 of the 4 plots that I can see whenever I log on to this site, either through my phone or my PC. I get water flow. Here I have a 7-day scale. Cumulative gallons per month, a 3-month scale. So this is 1 month, 2 months, 3 months. At the end of the month, I reset the count, and it goes back to 0 again. So this month it was 1,000 gallons. This month, only 500 gallons. And then motion, here's over a 7-day period. So that's my project. I really enjoyed working on it. It was very frustrating for a while when my web services didn't operate the way I thought they would, because they were too slow. So that might be a performance issue for you too if you decide to do something like that. But the Raspberry Pi saved the day, and I'm glad I ended up using it. And now, of course, now that I'm monitoring it, no more water leaks. I guess that's the Heisenberg uncertainty principle in operation. Thank you.